Welcome, welcome. I'm Dr. Tony Nettleman, and I saw on Reddit Land Surveying Forum recently a post by presumably a student or someone preparing for their exam, and they asked for some help with a surveying problem. Well, there were a lot of different people posting, and several of them had different ideas on how to solve this problem, but I did not see an answer solved step by step. So I thought I'd take a few minutes this morning and solve this problem. Now, first of all, I'm going to violate a principal rule of being a professor, and that is I am going to skip all the extra computations, and I'm going to solve this with my trusty HP 35. Why am I doing that? Well, if you were going to solve this by hand, it would take you probably 3 or 4 times the amount of time you have during an exam, probably at least 10 minutes by hand. But if you would like to see the hand computations, feel free to ask, and I'll be glad to sit down and do them. So without further ado, let's jump into this problem. Set this guy up. We have 4 points, D, E, F, and G. And we're asked to solve for some kind of an imaginary point in the middle of this, which is called point X. Is this in the direct center of the polygon? Probably. But let's not do anything crazy. Let's just diagnose the problem. Another thing I'm going to add is that these dotted lines are nothing. Completely ignore them. They're just showing you that this thing forms a polygon, but it really makes absolutely no difference. What I am interested in is 2 lines, FD and GE. Now, no matter whether you go up to down or down to up, who cares? But I really like to use whole numbers, and I like to do it in this direction. Why? I have no idea, but let's do it going kind of like south to north. This problem is going to be solved in 3 steps. The first step is computing the azimuth of FD. The second step is going to be computing the azimuth of GE. And the third step is going to be using our 2 points, where our starting points, and the azimuths to come up with X. So let's do it. Step 1, XEQI for inverse. Point 1, F, 2212, 1560. Point 2, 1198, 1756. The distance I don't care about, because this is a bearing-bearing intersection. But the azimuth I do. So the azimuth of FD, AZ equals 280. And I love this calculator because it gives me degrees, minutes, seconds with no BS conversions. XEQI, first point is G, 1400, 1200. And then 1997, 2011. And I love working with whole numbers because this sure does make it easy. Don't care about the distance, but I do care about the azimuth. 36, 21, 28. So I have the azimuth of my first line. I have my azimuth of the second line, and I want to know where these two meet. Now, the last step, once I have my 2 azimuth values and I have my 2 starting points, is to run this bearing-bearing intersection. Now, as surveyors, we call it bearing-bearing, but as mathematicians, we are going to call it line-line. So let's put this in. Point 1, 2212, 280.1560. Azimuth, 280.5624. Next point, 1400, 1200, 36.2128. Now this is the moment of truth, and this is what really scares me, because I wonder, am I going to get the same answer? So my x value, 1733.14, could be either of these two. Oh boy, this is kind of close too, but this one is dead on. Y, 1652.56. Woo, look at that. Those are some nice values. Now, on the real exam, you should probably expect to be a 100th or a 10th off from the right answer sometimes. So keep your eyes peeled for possible answers, which could also be true. But gosh, we were dead on this, and we'll call this a winner.